Hey everyone. For Notes 12, we're going to talk about log transformations. And for now, I just want to start with giving you a little bit of background about what they are. So what we saw at the end of Notes 11 was that sometimes if we check our data and the normality assumption, so this idea that our data came from a population with a normal distribution, or the equal variances assumption when we've got two groups, and the assumption is that the two groups came from populations that had the same variance. In cases where one or both of those is not a reasonable assumption, we need to do something else to be able to analyze our data. And so one option is to use this natural log and do what we call transform our data. And so we should understand what this natural log that we're talking about is before we get too deep into that. So the natural log is a function, but before we can understand that, we should define the number e. So a lot of you probably know that pi is a number. It's 3.1415, and then you can kind of keep going on. E is sort of a similar thing. It's a number that repeats forever, and so you can't just write it down as like 10/13ths or anything like that. But it has these really nice uses, and so we need a way to refer to it. And so we call it e. And you could actually try to calculate e by taking 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 and so on. And if you did that forever, eventually you would get this number that's around 2.718. And we would call that e. And what the natural logarithm function is, or the natural log function, is it is a function that if we put e to the x inside of it, we just get back x. So for example, the natural log of e to the 1 is just 1. The natural log of e to the 0 is 0. Natural log of e squared is 2, and so on. And so you can think of the natural log function as sort of undoing this process of raising the number e to some exponent. And it's sort of like square root and squaring something. So if I square something, the square root function undoes it. If I take e to some power, the natural log function undoes that. And it might help to look at the natural log function to sort of get a sense of what it looks like. So I've got my x values here, I've got my y values here, and then this sort of bluish purple line is the natural log. So you can think of it as, well, when x is 2, so when I take the ln of 2, it looks like I get something a little less than 1. All right, so we might ask ourselves some questions about this function. If I look at this picture, what does it look like are the possible x values? And you can sort of see that this line seems like it would just sort of continue going on this way. But as it goes to the left, it sort of slopes down really quickly, and it looks like it really doesn't want to cross that line right here. And the truth is that it'll never actually get all the way over there. And so we can't have negative x values, we can't have 0, we can only have positive x values for this function. All right. What about the y values? Well, this line is going down really fast, so it looks like we can have lots of negative y values. This line is kind of continuing up, so it looks like we can have positive y values. Here's a y value of 0. So we don't really have those distinctions like we have for x. So we can only put positive x values into this function, but we can get back out positive, negative, 0, and so on. So we might wonder, okay, well, where does the x value, at what x value does the function cross the x-axis? And you can see that right here is our x-axis, and this function crosses at x equals 1. So we might wonder, well, why is that happening? Well, we saw above that the ln of e to the 0 is 0, so our y value is 0 right here. And if you remember anything about raising something to the 0th power from like a previous math class, any number to the 0th power is just 1. So this is really another way of saying if I take the natural log of 1, I get 0 back. So when x equals 1, y equals 0 here. And then the one other thing I want you to look at is, well, if that's where it's crossing the x-axis, let's think about what's happening for values below 1 and values above 1. And you can see that if x is between 0 and 1, we're getting negative y values. If x is above 1, we're getting positive y values. So that's just an overview of what it looks like. Let's look at a couple examples. You could do this on your calculator, you could do it in Google, or anything like that. I've calculated out some of these just to show you. We already saw that the natural log of 1 is 0, but you might want to verify that. We know that e to any power, we just get that power back. These ones you could just plug into a calculator. So let me actually bring up, I've got SAS here, but what I usually like to do is just use Google. And if I can remind myself, I wanted ln of 8. So I'll take ln of 8, and you can actually see it went above my screen there, but ln of 8 equals 2.079, and if I go back to my notes, that's what I've got here. And you could try this on your calculator. If I put in ln of 0.5, I get a negative number. That makes sense. That's what we saw in this graph here. And we saw that we can't put in x values less than 0, so we can't put in negative ones. So if you do this on your calculator, you'll probably get an error. If I go over here and do it in, do it in Google, you'll see that it doesn't give me an error. So if I put ln of -5, it looks like some really weird like number plus, this actually might look familiar as pi to you, and then I've got this letter I. This is something called an imaginary number. We are not going to worry about it in our class. We'll just say, can't put negative numbers in. All right. So the one last thing that I wanted to show you then for this first video for Notes 12 is what this might look like in SAS. So if you have a calculator, you might notice that a lot of times you have a button that says log, and then you also have a button that says ln parentheses, sort of more like this. That is the difference between log base 10, so where 10 is this number that I'm raising to different powers, versus ln, e is this number that I'm raising to different powers. The reason I'm pointing this out is that in SAS, the word log actually refers to the natural log. So we're not going to type ln, we're going to type log parentheses. And here's some code on the left. And I put this into SAS just to sort of show you what it's doing here. So here's that code without the line that says log x equals log parentheses x. I'm going to run it, and you'll notice that it is telling me that I've got 1 column and 4 values. So I've got data values in a variable called x of 1, 2, 8, and 3. Now, if I go back here, we've seen something like this before. We saw back when we talked about paired problems that sometimes we've got our data and we want SAS to calculate something for us. And so one nice thing that we can do is we can say, okay, here's my original data that I read in. I want the log, the natural log specifically, of each of those x values. And I want to calculate it for everything in my data set. So what I'm going to do is I'm going to create a new variable that will be called log x. And to do that, I'm going to take the log of each x value. So we've seen this before where we did something like diff equals unaffected minus affected for the twins example. And what you'll see is that when I run this code now, I should have actually 2 variables. I've got x, and I've also got log x, and SAS has calculated the natural log of each of those numbers. And this is good because this means that now if I want to use log x in my analysis, I've got each of those values that I can use. All right, so in our next section, we'll actually look at an example where we do a little bit more with this, but this way you get a little bit of background about what we're doing, why we're doing it, and even how to add this into your SAS code.